Unit 13, day 6. And actually, it's day 6 is, or this lesson is a 2-day lesson. Half-angle identities. Day 1 of 2. So tomorrow is similar today, obviously different enough to warrant its own day, though. So you've got sum and difference formulas. You've got double formulas. Today we're going to do half formulas. So the sine of x over 2, hence the name half angle, equals, these are more complicated, but it's open notes, you'll have these, but these are complicated enough that even in normal years, we give you these. Plus or minus, big square root, 1 minus cosine of x over 2. Cosine of x over 2 equals plus or minus big square root 1 plus cosine of x over 2. Okay, let me give you the tangent one, and then we need to talk about them for a minute. Tangent of x over 2 is 1 minus cosine of x over sine of x. So one of those rare instances where tangent is easier than sine or cosine. So we've never used these before, but we've done things like this before, where I give you a picture, I give you an angle, and you just apply the formula, and then take care of the algebra, and come up with an answer. The big thing with these is that plus or minus, it's not both, okay? This is different than usual. Like with the, you tell me, what formula do you see the plus or minus in? What are you most familiar with that has a plus or minus in the formula? The quadratic, good, yeah. It's x equals negative b plus or minus, and so you get two answers. Here, though, this is different. It's not both, like the quadratic is both, that you get two answers. Here you have to pick. You must choose whether it's positive or negative. So it's not both. The plus or minus is there to remind you to pick the right one. And you choose based on the quadrant of x over 2. So this is an easy way to tell who was paying attention and who kind of wasn't. And just wrote down formulas. When it comes to the test, if they put plus or minus, it means they weren't really paying attention. You got to pick one. I mean, you might pick the wrong one, but you can't put both. You got to pick one or the other. It's not hard to do, and I'll show you how. It's just you got to remember that it's plus or minus is part of the formula, but it's not both. You got to pick which one to use. Let's do an example. Let's say tangent of theta is 5/12, and theta is between pi and 3 pi over 2. Like that's been the start of, I feel like, most of the problems in this unit. It's like draw a picture of this triangle, and then we'll do some stuff with it. So pi to 3 pi over 2 is third quadrant. Tangent is opposite over adjacent, or y over x. So 5/12. That's a 5/12/13 triangle. And what's wrong with my picture? The negatives. Who's negative? 5 and 12. So hopefully we're not messing negatives anymore. We're just hyper aware that when we draw a picture, we better be careful. If it goes left or goes down, then they're negative, or those sides are negative. let's find the sine of theta over 2 and the tangent of theta over 2. So sine of theta over 2, I'm copying down the formula, plus or minus 1 minus cosine of theta all over 2. Again, it's not plus and minus, it's plus or minus. I don't know which one yet. We'll worry about the plus or minus in a minute. Plus or minus, square root, 1 minus cosine of theta. Well, this picture is theta. So cosine of theta is negative 12/13 all over 2. Now, we can use the calculator here, sort of. Because if we put the square root in the calculator, we're going to get a decimal, and we can't ever undo the decimal thing in the calculator, right? There needs to be a math square root button, like there's a math frac button, right? If you do 1 divided by 3, you can go math frac and get 1/3 back. But if you do square root of 3, you've lost, you can't, right? Like one of you needs to invent the math, like turn it back into a square root button. But no one's invented that yet. So here's what's gonna go in the calculator. Everything but the square root. I mean, you can do it by hand, but it's just easier to put this stuff in the calculator. So plus or minus square root. So rather than mess up the fraction stuff, I'm gonna put it in the calculator. And again, all the warnings about parentheses and division or fraction bars, however you want to put it in there. Fraction bar is always the safest way, but I'm going to change it to 1 plus 12/13 over 2. So I kind of opted for the part fraction bar, part division symbol. Well, that's yuck, but thankfully there's a math frac button. 25 over 26. So use the calculator, but use it carefully. Don't plug it all in there, or else you're going to get the square root and you'll never figure out what is supposed to be under the radical. This is convenient, and I feel like this happens often. Maybe not every time, but often. I can take the square root of at least the top part, and then that's a pretty easy fix. You fixed hundreds of those in your math career by now. So 5 square root 26 over 26. But I still have this plus or minus on there, and I need to think about where theta over 2 is. So this angle is theta. So I need to figure out where half of that angle is. There's a couple ways to do this. Some people can like visualize where half of that angle is. Because all I need to know is what quadrant it lands in. So I don't have to be perfect with it. So some people can say, well, I don't know, half of that angle probably is like right there. And if you can visualize it, what's that? You're like, how do they do that? Exactly. If you can visualize it, that's fine. If you can take half of that opening, let's see, that opening is more than 180. Here's another way to do it, sort of mathematical. So half of more than 180 would be more than 90. So it would be into the second quadrant. If you can handle that, that's fine. Here's how I think is the easiest way to do it. Theta is in quadrant 3. Like everybody can handle that, right? Theta is in quadrant 3. That means theta over 2. This is sort of made up algebra, but it works. I can divide both sides by 2, right? That's legal, sort of. So theta over 2, I'm going to get real fishy here. What's 3 divided by 2? Go ahead, what's 3 divided by 2? 1.5, which feels weird because there is no such thing as quadrant 1.5. But what does 1.5 round to? 2. So that means theta over 2 would be in quadrant 2. So you can divide the quadrant by 2, round appropriately, and find the new quadrant. To me, that's the easiest, safest way to do it. So if we're in quadrant 2, and we want the sign, in quadrant 2, the sign is positive. So 5 root 26 over 26. So some quadrant algebra, which is a little bit fishy. Like, what am I doing dividing quadrants by 2? But it always works. It always works. This was only the first half of that problem. Tangent of theta over 2 is 1 minus cosine theta over sine theta. Looking at my picture. Like, again, we've done this type of problem a whole bunch of times by now. So we have a new formula, but we've done this before. Just look at the picture and fill in the blanks. So cosine is negative 12/13, and sine is negative 5/13. And if you're feeling brave, you could do that by hand. If you're not feeling brave, then you could do it in the calculator. 13 plus 12, 13. I'm going to do it by hand because it works out. 25/13 over negative 5/13. I think I can do this one by hand faster than I can type it in the calculator. Keep it, change it, flip it, and you end up with negative 5. And for tangent, you don't have to worry about the plus or minus. Or I guess I should say it takes care of itself. We're in quadrant 2, so tangent should be negative, so that works. All right, the main thing I'm worried about is the quadrant situation. So I'm going to do another example, but I only want you to find the quadrant of x over 2 if sine of x equals 5/13 and cosine of x is less than 0. So draw a picture based on this. That would be a picture of x, and then use that to figure out the quadrant of x over 2. I'm going to pause. If you're at home, pause the video, give that a try. So picture of this, figure out what quadrant x is in, and then figure out what quadrant x over 2 is in. So if sine is positive, you're in quadrant 1 or 2, right, the up quadrants. If cosine is negative, you're in the left quadrants. So if you need to be up and to the left, you got to end up in quadrant 2. Now, that's not the answer to the question. That's for x. So quadrant 2, opposite over adjacent. Missing side to be 12 and is negative. So x is in quadrant 2. Oh, I'm recording. Oh, I'm recording, but I didn't unfreeze the... It's so complicated. Catch back up here. Sine's positive, that's quadrant 1 or 2. Cosine's negative, that's 2 or 3. So to fit both of those criteria, you got to land it in quadrant 2. But that really wasn't the answer. That's the quadrant of x. I want the quadrant of x over 2. So we're going to do some quadrant algebra. Divide both sides by 2. So that means x over 2 is in quadrant 1. That one's maybe a little bit easier to visualize. Like, here's the angle. So half of that angle is, I don't know, somewhere in there. And you don't have to be perfect, because all you gotta do is land in the right quadrant. So even if your visual skills aren't perfect, they should be good enough to get you in the right quadrant. And then you could answer questions about who's positive and who's negative. All right, big deal for today is that on worksheet number 5, worksheet 5, I think. Yes, on worksheet 5. The homework is 1 through 8. Right? Does that not look right? Yeah, 1 through 8. So on worksheet 5, 1 through 8, 9 through 12 we'll do tomorrow. It's more half angles, but it's a little bit different. So just 1 through 8 for today. And in fact, 1 through 4 are double angles, so that's practice. That's old news. And then 5 through 8 are the half angle stuff. So some built-in practice from old stuff in there.